So this is the video for the first day of 2.6 special functions. 2.6 is complicated. There's a lot of different things going on here, so that's why I've broken it up into 3 days. This first day, we're going to focus just on absolute value functions. And we've dealt with absolute value before with equations and inequalities, but we've not looked at their graphs yet. And so here's an example of a problem that we're going to look at where f of x equals the absolute value of 2x minus 4. And remember that you can always think of f of x like it was just y equals the absolute value of 2x minus 4. Okay? It's the same idea, same concept. This doesn't mean f times x or anything like that. It's just the name of a function called f, and its input value is x. A couple things to know about absolute value functions, and as you watch this video, as you're taking notes, feel free to pause and rewind as often as you need to in order to make sure you're confident moving forward. Absolute value graphs are shaped like V's. They will always have a sharp point to them every time you have an absolute value equation. Okay, they could be facing up, an upward V. It could be an upside down V. Later on in other math classes, you'll see that they can be on their sides too. But anytime you see this absolute value inside an equation, just know that the shape is going to be a V. Okay, and what I like to do initially is start with the table of values to try to graph this, and then of course after we do that, we'll identify the domain and range. And we need the graph in order to find the domain and range. So I'm going to start super easy. I'm going to start with my x values. Again, I just pulled a grid off the internet. You can do that, or you can turn your graph paper on in Notability. It's up to you. So I start off with some easy points. Now you're going to need a bunch of points. Just I'm forewarning you right now. And in some cases, you may end up with 5, 6, 10 points until you really feel confident about what the shape of the graph is going to look like. And once you get that, once you have that confidence, then you can stop coming up with more points, and that way you'll know exactly what the graph looks like. So in this case, I plug 0 in. Okay, in reality, if I plug 0 in here, this whole thing just ends up being 0. Okay, the absolute value of 2x is, or 2 times 0 is 0. Absolute value is 0, 0, which makes this value, this function, equal -4 when I plug 0 in. Okay, when I plug 1 in, this is 2 times 1, which is 2. The absolute value of 2 is 2, so 2 minus 4 is -2. And so pause the video, find the rest of the values. So in this case, when I plug 1 in, I've got the absolute value of 2. 2 minus 4 is -2. You should be able to predict what the next ones are going to be, but we'll plug 2 in anyway. 2 times 2 is 4. The absolute value of 4 is 4. Minus 4 is 0. And the last one, of course, if I just follow the pattern, it's going to be +2. And notice now I've added those points to my graph. And here's where the dilemma is going to come in when you're doing this on your own. The question is this the right side of a V going up? Is this the left side of a V going down and the rest of the V's over here, right? Or is it a V that looks like this? The problem is we don't know. And you have to decide where the graph is going to take the turn from just being 1/2 of a V to being a 2nd half of a V, whether it's this way or this way. And so at this point, what I would say is I would experiment with some points to the left to see if it starts making a turn up. And if it doesn't, and the next point ends up being down here, because obviously we've got a pattern, then you're better off looking for a point over here to try to see if it makes the turn on this side, because it's an upside down V. And when we get into 2.7, I'm going to give you some strategies as to help make the determination of which direction it goes. But at this point, I want you to do it on really just a trial and error kind of basis. So my next move is I'm going to go ahead and move to where x's are negative. So I'm going to go with x of -1, okay? And when I plug that in here, I get 2 times -1, which is -2. The absolute value of -2, of course, is +2. So 2 minus 4 is -2. Okay, and notice on my graph, it did make the turn. It started going back up. So I know the shape of the graph now is going to be a regular upright V, and I see that it's going to make the turn. This is the thing that, worked out nice for this problem. There will be some problems that you will encounter where you'll keep picking points, and you're like, all right, it keeps going down. It's not making the turn. But the other thing is let's say you keep going down here, and you do try to find an x value over here to see if it turns down over there, and it still doesn't. It might not make the turn to go up until somewhere over here. So you're going to have to play with it a little bit and experiment with it a little bit. Part of the reason I didn't give you that many problems to do for homework is you are going to have to play around and experiment and see where it makes the turn. Now you have some other tools, of course, that you can rely on to help give you a better idea of what the graph is. Just understand that come test or quiz time, you're going to have to generate that stuff on your own. So in this case now, if you notice, it looks like it reflects about the y-axis here. And so if these 2 points are reflected, I should be able to find a point over here, 2 away from the y-axis, and 3 away from the y-axis. So I can come up with those other points just by observation, really. Looking at the symmetry of this shape, see how far away the point is here, and go the same distance the other way. And then I've got my, in this case, I've got 2, 4, 6, 7 points. Now I really only had to find 5, and I came up with a couple others just by looking at the graph itself. And so I can then go ahead and draw my V in there and show what my absolute value function is going to look like. So the process for graphing is going to be just like this. Now we've got one more thing that we need to do, which we haven't done yet, and that's identify the domain and range. And when we use a graph, a continuous graph like this, to determine domain and range, we have to look for boundaries or gaps. If there are any gaps in the line itself where it's not connected anymore, then we're going to have to account for that in some fashion. And we'll spend more time with that when we get to day 2 of this lesson. But in this particular case, I don't have any gaps, right? These lines are completely connected, and they go on and on forever and ever. There's no gap whatsoever. So what that really means is, in terms of looking at the domain for x's, for every x that I move, right, there's going to be a point on the graph, right? No matter where I go, there's going to be a point that matches up with x. There's no gap. And all these x values, and I'm just moving along the x and then hitting the graph, right? So there's always going to be an x value for this graph. No gaps, no spots that get missed, nothing like that. Therefore, the domain is all real numbers, okay? So when I set up, that's how I'm going to write the domain. Now, I look for the domain, I was looking for these boundaries or holes or gaps, and I didn't see any of that. Now for the range, what I want to do is see if there are any boundaries. Okay, the one thing I can tell you for sure is that this graph goes up and up forever and ever. There's not going to be an upper boundary. There's not going to be a ceiling that sort of caps this graph. It's going to go up forever and ever. But if you notice here, there is a bottom boundary, right? None of the graph ever goes below this point, right? The entire graph is bounded at this line right here. And all the values above for y will be on this graph somewhere, okay? So, here's what that means. That means because I have a bottom boundary, I'm going to have an inequality that I use to represent the range. And in this case, normally I could say y, but it's really f of x. So my boundary, okay, and I'll be real honest, I don't care if you write y or f of x, but you technically should write f of x. And my lower boundary here is at y is -4. And -4 is on the graph. That point is closed. So -4 is part of the range. And then everything above -4 is also in the range. So what my ranges look like is f of x greater than or equal to -4. So my lowest boundary, my lowest y that I could ever have for this particular function is -4, and I can be greater than or equal to it. So that's what you're going to be doing for 2.6 day 1. You're going to be graphing using a table of values. You're going to try to figure out where it makes the turn, so that, because it goes up to the right and up to the left, or in fact it might flip over and be an upside down V. You're going to look for boundaries. If this did open down, then instead of it being greater than, it would be less than, because I'd have a top boundary and everything below it. All right, so it's a two-dimensional inequality, and we're used to seeing, we had a number line where we do an open or closed circle, and we draw an arrow to the left to be greater, draw an arrow to the right to be less than. Now with 2 dimensions, we're talking about up and down, and so that's where this comes from. Okay, all right, so that's 2.6 day 1. Pretty short. You've got a handful of questions that are just like this, and let me know if you ever have any questions.